All right, so our chapter 5 packet, this is the shortest packet, hopefully. So we'll try to get through this quickly. And reminder that every question is non-calculator unless it specifically tells you that you can use a calculator. So this first question does confuse a lot of students, and that's because we're given the graph of x of t. Okay, we're a lot of times used to be giving the graph of v of t, but we're given x of t. And so we want to make sure that we realize that moving right is, when v of t is positive, but for x of t, that would be when x prime of t is positive. And so on an x graph, that would be when the graph is, x is increasing. But velocity increasing is not moving right. A lot of students confuse that. Velocity increasing is not moving right. Velocity increasing means that v prime of t is positive, right? V, increasing means take the derivative of that. So v prime of t is positive. Well, v prime of t is x double prime of t. So that's when x double prime of t is positive, which on our x graph would be when x is concave up. So this graph told us we had an inflection point at 2, and so we can see it's concave up between 0 and 2. All right, next, a particle moves in a straight line with this formula. What is the acceleration? This one's very easy. To get from velocity to acceleration, we just take the derivative and plug in the value 3. You can do this on your calculator, and you get the answer. It should be nice and simple. All right, next up, we have a similar question, but we're given position. We're asked for the particle being at rest. And this is a non-calculator one. So we need to make sure that we're connecting particle at rest with setting v of t to 0. So we're going to just do the derivative by hand. Make sure that whenever you can, you factor out a common term. So in this case, I can factor out a 6 from every term. And it's a nice, easy x method. We get 3 and 4. All right, 76 is almost identical to the question 2 before it. We're given another velocity, and we're asked for the acceleration at time 4. So we're just acceleration is going to be the derivative of the velocity at 4. So in our calculator, this is how we would type that in. And then we get our answer. All right, 27 is really, really tough. And I want to make a point about 27. Is if you get any question that says absolute max or absolute min on the multiple choice, literally what I want you to do is save this question for last. Okay. You have 2 minutes per question on the non-calculator multiple choice. You have 2 minutes. This question is for sure going to take more than 2 minutes. I mean, look at all the work that I had to do. So for sure, this is going to take you a lot longer. So the best bet, honestly, is to just, try to just take a random guess if you don't have enough time, but to save it for the end. You can kind of on the multiple choice, you can kind of cheat a little bit, and you don't actually have to show all this work, and you can just plug in all of these numbers. But sometimes that ends up taking even longer, because if you notice, we never had to plug in 4. You can also cheat a little bit. On the free response, they want to see the full table, but you can cheat a little bit and make a number line. And so I'll kind of show what I mean by that, and we would want to have endpoints, but let's kind of take this from the top. So, once you've finished all the other questions, you've come back to this one, right? Now, for absolute max, we're going to take our derivative, set it equal to 0, and we get x equals 2 and 6. And then we make our table. And so we have 0, 2, 6, and 9. Those are our possibilities. And so we're going to plug in f of 0 is nice and easy, right? F of 0 is just -5. Then we plug in f of 2, f of 6, and f of 9. But I said we could cheat a little bit. So if we want to cheat a little bit, what we could do is we could say, okay, between 0 and 9, right, for f prime, we have critical points at 2 and 6. If I plug in 1 here, 1 minus 6 is negative, 1 minus 2 is negative, so we get a positive. I'll kind of do the shortcut. They're both odd exponents, so I know it just switches back and forth. So our graph is increasing, decreasing, and increasing. And so what's going to happen is the only times I actually could have a maximum here would be at 2 or at 9. So we actually don't even need to plug in 0 or 6 because those would be, for the possible absolute minimums. So we could kind of save ourselves a little bit of work by not having to plug in 0 or 6. So that's something that you can do to kind of basically speed up the process a little bit. Don't do that on the free response, though. Just plug them all in on the free response. Okay, for 13, let f be the function x cubed minus 3x squared, and which of these would satisfy the conclusion of the mean value theorem. So mean value theorem is when we take f prime of c, we set that equal to f of b minus f of a over b minus a. So on the right, I like to do f of 3. F of 3 would be 3 cubed is 27 minus 3 times 9. 27 minus 27 is 0. F of 0 is also 0. So this actually ends up being Rolle's theorem because they're the same. And so we kind of see that 0 minus 0 over 3 minus 0 is 0. So we're taking the derivative, setting it equal to 0. 3x times x minus 2 equals 0. We get 0 and 2. Now be careful. Do not pick the answer that says 0 and 2. In this case, there wasn't one. But if there was one, don't pick 0 and 2. Why? Because we need to check these two values and see, are they in between 0 and 3? Well, 0 is not in between 0 and 3 because it's an endpoint. So it's only 2. All right, next up we have another particle at rest question. This is a non-calculator question. We need to be comfortable solving for e to the x equal to 0 by hand. So this is a good one to practice if you need help with those. So this is product rule. The derivative of the first is the t part. So we get 1, leave e to the negative 2t alone. Then plus, leave the t part alone, times, now this is going to be chain rule. So e to the box times the derivative of the box is negative 2. So this is e to the negative 2. I just brought the negative 2 to the front, minus 2t e to the negative 2t. Both terms have an e to the negative 2t, so we can factor that out. We get e to the negative 2t times 1 minus 2t. Then we're going to set both sides equal to 0. So e to the negative 2t equal to 0. Remember, we've done this a bunch of times now. E to the x equaling to 0 has no solution. If you want, you can do like ln of both sides, and ln of 0 is undefined, so that's why it has no solution. Or you can remember the graph, right, of e to the x, it never passes through 0. Right, or 1 minus 2t equals 0. And in that case, we get t equals 1/2, right here. And then what's going to happen is we end up having 1/2 as our answer. Okay, next up, the absolute maximum value of f of x equals x cubed minus 3x squared plus 12. Again, another one of these absolute max. So I would immediately, if it were me, I would save this for the very end and do this at the end. And we're going to take f prime of x, set that equal to 0. We get the possibilities of 0 and 2. And then we're going to plug in all of these values, right? So our endpoints, negative 2, 0, 2, and 4. We plug all of them back in to f of x. Now, I said we could kind of do that shortcut and save some time. So if we wanted to do the shortcut, if I plug in -1 here, I get negative, and negative is a positive. This is to the first power to the first power, so I know it just flips back and forth. So it increases, decreases, and then increases. So again, the only ones I really actually need to plug in would be 0 and 4. Those are my possible maximums. So I could have saved myself some time, right? Especially because plugging in 0 is super, super easy. So really all I had to plug in here was 4. So you probably could have done this question in close to 2 minutes. All right, next up we have another mean value theorem question. And this is almost identical to the one before, so I'm not going to spend too much time on it, right? Take the derivative, 3x squared minus 4x. Set that equal to f of b minus f of a over b minus a. We end up with 0 again. 3x squared minus 4x equals 0. This, we can't do x method, but you always want to look to factor out a common term. We can factor out an x. So you get x times 3x minus 4 equals 0. And we get 0 or 4/3. Cross out 0 because it's one of our endpoints. All right, next up we have a position of a particle, and we're asked what is the acceleration at time 4. So we need to just kind of remember that ladder, right? Position, velocity, acceleration. To get from position to velocity, we need to take the derivative twice. So the first derivative will be velocity. Derivative t squared plus 4t is 2t plus 4. Then our second derivative is s double prime is a of t acceleration. Derivative of 2t plus 4 is 2. Then we do need to plug in 4 into that. But since there's no t value, the acceleration is always just 2, actually. All right, next up, we have the position of a particle is negative 5t squared, and we want to know the average velocity. So average velocity, we do have two options. We have position at B minus position at A over B minus A, or we have 1 over B minus A times the integral from A to B of the velocity of t dt. But it's dependent on what we're given. If we're given velocity, we use this formula. If we're given position, we use this formula. So we're given position, so we're going to use this formula. So just x of 3 minus x of 0 over 3 minus 0. We plug in x of 3, negative 5 times 3 squared is negative 45. Plug in 0 is 0. And you end up with negative 15. Okay, next up is a Rolle's theorem question. Rolle's theorem has three conclusions. F has to be continuous, which is A. F has to be differentiable, which is B. And f of A have to equal f of B, which is C. So our answer is all three of these. Okay, next up, we have a particle motion question where we're given position again. This one's a little bit tricky. You just have to be careful on these. It asks, what is the velocity? So we're plugging into the velocity when the acceleration is 0. So this was a calculator question. On my calculator, took the first derivative, right? I did that up here. The first derivative, we got 4 sine of t minus t. Now, if it's multiple choice, you want to write this line. Then I did the second derivative, which is 4 cosine of t minus 1. Again, if it's free response, you want to write this line. Multiple, I think I said that backwards. If it's free response, we write those lines. If it's multiple choice, you don't have to, but it does help me to organize myself. So we want to know when the acceleration is 0. That's going to give us like a time, right? So we're going to solve 4 cosine t minus 1 equal to 0. So I did that here. Make sure you put this interval in. If you don't put that interval in, you're not going to get the right answer. So we get t equals 1.318. And we're going to take that value and we're going to plug it into the velocity, right? So we're going to plug it into our velocity. So velocity at 1.318, I did in this last line, and we get 2.55. All right, next up is another position, and this is another one by hand. And we want to know the acceleration. It's very, very similar to this question that we just did up here, question 11. Except it's with trig, so we just need to make sure we know our trig. So we have, where are we? I think I skipped that. All right, we have our first derivative is the velocity. So the derivative sine of 2t is outside is cosine of 2t and then times 2. Then the derivative cosine is negative sine. That turns to positive sine because of the negative negative. So it's positive sine of 3t times 3. I just moved the 2 and the 3 to the front. You could have done that in 2 lines. I just moved it to the front. Then we're going to do the acceleration. So again, this is another chain rule, right? So the 2 is going to hang out in front. Derivative cosine is negative sine of 2t times 2. So I just kind of combined the 2 and the 2 and the negative to make negative 4. You could have done this in multiple lines if you needed to. Then plus the derivative sine is cosine of 3t, so cosine of 3t times 3. 3 times 3 gives us 9. Now I plugged in pi, and since it's 2t, that's going to be 2 pi. So make sure we know our unit circle. And then here was 3t, that's going to be 3 pi. Now 3 pi is the same position at pi. So sine of 2 pi is 0, cosine of 3 pi is negative 1, 9 times negative 1 is negative 9. All right. This one says, if a function is differentiable on negative 4 to 4, then which statement is true? F is not continuous. We have no clue if it's not continuous on negative 5 to 5. We do know that it's continuous on negative 4 to 4. That has to be true. But negative 5 to 5, we don't know. Same thing for B. We know it's differentiable on negative 4 to 4, but we don't know about negative 5 to 5. C says f prime of C has to be 0 for some interval. That's Rolle's theorem. We don't really know that. The only way we would know that is if we knew that f of A, or really f of negative 4, was equal to f of positive 4, then C would have been true. Right, or if we knew it had a horizontal tangent somewhere. And then D says the conclusion of the mean value theorem applies to f. Well, yes, that's because if a function is differentiable, then it's continuous and mean value theorem applies. All right, next up we have the maximum acceleration. This is similar to those other maximum problems. So again, I would probably save it till the end. We know it's maximum with any endpoints is that absolute max. And now be careful about this, because what do we want the maximum of? We want the maximum of the acceleration. So we're going to make a table that has, a lot of students get confused here of what goes in the table. The table needs to have t and a of t. And that means we need to set a of t to 0. They gave us v of t, so they were tricky. They gave us v of t, but we need to set a of t to 0, and we're looking for stuff about a of t, because we want max acceleration. From v of t to a of t, we take the derivative of 1. So we get 3t squared minus 6t plus 12. Now, we're not going to set this equal to 0. A lot of students want to set this one equal to 0. But because we want the maximum acceleration, you always want to remember that when we see maximum, we take the derivative of whatever that is, and then set that to 0. So we need to take the derivative of a prime, 6t minus 6, set that to 0, we get t equals 1. So now we have options of 0, 1, and 3. And we'll plug each of those back into a of t, right? So 3t squared minus 6t plus 12, nice and easy. Now, if you want to, do that shortcut I was talking about earlier, would be you could, between 0 and 3 for a, right? Our critical point was at 1. So like 0.5, 6 times 0.5 is 3, 3 minus 6 is a negative. And say 2, 6 times 2 is 12, 12 minus 6 is a positive. So we could actually get rid of 1 and only plug in 0 and 3. Okay, so that's kind of how that works. Okay. Next, a particle starts from rest. This one's really confusing. Okay, it starts from rest at the point 2, 0. And so a lot of students, they'll try to pick C or they'll try to pick D. But this is actually a little bit confusing, because let's look at what the y-axis is. The y-axis is the position. So the y-axis is the position. So if it's starting at the point 2, 0, that's a little bit tricky, but it's starting at that point on the x-axis, right? This is not the x-axis. So I kind of drew this down in the bottom left, and we can kind of zoom in here and look at this. So on the x-axis, our point's starting at this point 2, right? And really, this is more of on BC, they're going to say 2, 0. On AB, they're just going to tell you it starts at, x equals 2, and you're not going to get confused like this. But it starts at this point 2. And so that's where it starts, and so that means that the position at time 0 where it started, the position was 2. So actually we can cross out C and we can cross out D, because it has to start at a position of 2. So that's how, we kind of looked at that. So we're between A, B, and E. Now, the second thing it tells us is that it has constant positive acceleration. Well, acceleration matches with x double prime of t, right, which is concavity. So it needs to be concave up. So that's choice A. All right, next, suppose a particle is moving along a coordinate line, and its position is given by 9t squared over t squared plus 2. When would the instantaneous velocity equal the average velocity? This is actually MVT. It's another word, name for MVT, or kind of writing out MVT. But we're going to basically instantaneous velocity. We will take the derivative of s of t, right? And then we will set that equal to basically f of b minus f of a over b minus a. So I wrote v of t here, but it may have been even better to write like s prime of t. Right, taking the derivative is equal to the average value formula. So I did the derivative on my calculator right here, and I got 36t over t squared plus 2. That's on the left side. Then on the right side, I just plugged in t at 4, we got 8, and t at 1, we got 3. And then we did the solve button. So we did solve of, all of that, and then make sure you do the interval, and we got t equals 2.2187. If you're wondering why do I get this little error message, it's like a warning flag. It's just, the reason it gives you a warning flag here is because the domain is not all real numbers, right? Like the denominator could hypothetically be 0. And so that's where we get that warning flag. So a lot of times, anytime you have a fraction, they'll kind of tell you, hey, the denominator here, we might have a no solution, but we might not catch that. So you need to be aware of that. Okay, 822 says, why would the mean value theorem not apply to f of x equals the absolute value of x minus 3? Well, remember, MVT just has two conclusions. F has to be continuous, and f has to be differentiable. Well, if we graph, absolute value looks like a v, it is continuous, but it's not differentiable. All right, next, this function does not satisfy Rolle's theorem because, and so again, Rolle's theorem has three. G has to be continuous, G has to be differentiable, and then G of -3 must equal G of 0, -2. Well, they're both equal to 0, so that one didn't fail. But this graph is not continuous at 1, right? Like x minus 1 cannot be 0, so x can't be 1. So it's not continuous at 1. So it's choice C. Now, technically, it's not differentiable, but it's not differentiable because it wasn't continuous, right? So we want to always pick, that if that's true. All right, next, it just tells us to basically apply Rolle's theorem. So that means they're just asking us, do we know that Rolle's theorem means to take the derivative, set it equal to 0? So we're going to take the derivative of this guy, 6x squared minus 6, set it equal to 0. That's 6x squared equals 6, divide by 6, x squared equals 1, take the square root, x equals plus or minus 1. Now it's not C because we need to go back and check our endpoints. Our endpoints were from 0 to square root of 3, so -1 is not in the interval, so it's just the +1 case. Next up, which of these statements are true? Number 1, there is a horizontal asymptote at 0. Remember that horizontal asymptotes are way out, the limit as x approaches infinity or -infinity of f of x. So this horizontal asymptote is approaching y equals 0, so that's true. There are 3 inflection points. If we look at this, it starts concave down, goes to concave up, switches back to concave down, and goes back to concave up. So that is true. There are 3. It switched 3 times. But then it says there are no absolute extrema. Well, because this has horizontal asymptotes at 0, we're going to get an absolute maximum and an absolute minimum. And so there are 2 absolute extremas. So this is 1 and 2. All right, next up, this was a tricky question. I actually like this question a lot. And I kind of wish this question did have an answer so I could show you that. But maybe we can work that into it. So in this case, it gives us 2 positions. And it says for how many values of t do the particles have the same velocity? So we need to take the derivative of each to get the velocities. So I did that up here on my calculator, and I wrote it here. So we got negative sine of t and this weird 0.116 e to the t over 2. First, I tried it with the solve button, and it gave me something weird. It still has a sine of t in it. It still has a t in it. Basically, that's telling me, hey, your calculator just can't solve this one. Right? If you ever try to solve it and you get back at t and you have your interval, your calculator just can't solve it with the solve button. But it still will be able to solve it with the graph. So next what we did is I flipped over to the graph. I could have retyped in negative sine of t and 0.116 e to the t over 2, but instead I just typed them in as derivatives just to show that you can do that as well. But if you typed in negative sine of t and 0.116 e to the t over 2, you would get the same graph. And so what we want to do is, normally we'd go to menu, analyze graph, and we go to like zeros or we go to maximum. But in this case, if they're equal, there's one that says intersect. And the intersect graph wants to see where is the graph. We want to pick a value on the left of where we think it intersects and a value on the right of where we think it intersects. And so I kind of said, here's my left side, here's my right side. Maybe it intersects right there. And it didn't. It gave me an error. It said there's no intersection. So that means that there's nowhere where those graphs are the same. Now, if instead, just to kind of show this, like let's pretend we had a question like this, where like maybe x of t was equal to t minus 2 cubed times t minus 6 for our first particle, and then maybe our second particle was negative 2t squared let's say plus 1. Okay. So what we're going to do is we're going to grab our graph. And I typed in the first one because it's long. But on our graph, we're going to go to the derivative because we're trying to get velocities. So the derivative of, now it was t minus 2 cubed, but I need to change it to x because on the graph it always has x's in it. Okay, and then the second one, just to kind of show how I did this, is I'm doing derivative because I want to go get the velocity instead of the position. So the derivative with respect to now, instead of t, we're using x because it's on a graph. Okay. And then this second one was negative 2x squared plus 1. Oops, totally messed that up. So make sure you are in the right area. Okay. And so we see this now. If we get something like this where we're not sure what happens below, you can always change your zoom, right? I'm just going to hit zoom out. So menu, window zoom. Let's zoom out. It's going to ask us like, where do we want the new center of the graph to be? I'm going to say like, let's zoom out around there. And yeah, it does look like it might cross a few times. So we can even, if we want to, we can even zoom back in down there. So we could go to menu, zoom in. Let's say, let's zoom in more like, centering around there so we can kind of see this. So in this case, looks like it crosses 3 times. If it asked us for them, we would go to menu, analyze graph intersection. Go to the left of the first intersection, the right of the first intersection. So it gives us a point there, right? If I go to menu, settings, if I needed that point, I would probably want to change the float to be something more appropriate to get 4 decimals, right? And then menu, analyze graph, intersection, right? And I can kind of count them. Like if it asks me how many, I can just kind of count and see that it has 1, 2, 3. But right here, I go to the left of the intersection, then to the right of the intersection. Make sure not to go way out here or it'll give you the wrong one. Right, I'm going just beyond that first one. And I can just move this out of the way, click and hold it. Right, so there's my second intersection, and then menu, analyze graph, and intersection. So I go to the left of my intersection, this last one, and then to the right of my intersection, that last one. So this had 3 intersection points. Okay, now the other one, when I tried to do that menu intersection, what happened was we got this error message of there was no intersection. So that's why I picked 0 times. Okay, next up is another Rolle's theorem question. So it's asking about this graph up here, right? This graph. And it says, why does it satisfy Rolle's theorem? Well, because all 3 are true. If it does satisfy Rolle's theorem, they all had to be true. So this graph is continuous. It is differentiable. I know it does make a corner here at B, but remember it's differentiable inside of A to B. The parentheses means that this middle part is differentiable, which it is. The endpoints don't have to be differentiable. And then the endpoints are equal, so it does satisfy Rolle's theorem. Okay. This next one's super tricky. Honestly, it's way too hard for the AP test. I think I marked it as being a bonus question. So the first one says the particle is at a positive position. Well, a positive position, we wouldn't actually take a derivative. We would just take x of t and set it to 0. So you're going to get a and b. Like a and b would be the zeros. And then what I did is I just plugged in the first one. I plugged in 0, right? 0, it says 0 is less than a and less than b. So I plugged in 0 for t. 0 minus a is negative. 0 minus b is negative. A negative times a negative is a positive. Now, I didn't plug anything else in because I know that this is cubed into the first power. So odd exponents, it always changes. So we get positive, negative, positive. And so this is not increasing and decreasing. This is just because we're on x still. This is to the left or right of the axis. So a plus b over 2 would be in the middle. This is where it's negative. So I'll be in the negative position. So the first one fails. Again, if you want to skip this question, just skip ahead and don't worry about it. Number 2 says the particle is at rest at time A. So we need to take the derivative. This is a hard derivative. It's product rule. So the derivative of the first has a chain in it. 3 times t minus a squared times 1, and then you leave t minus b alone. Then plus leave t minus a cubed alone. The derivative of t minus b is 1. Then from here, I factored out a t minus a squared. They both had a t minus a squared. So when I factor that out, I'm left with in the first term 3 times t minus b, and in the second term t minus a. From there I just distributed, and then I added like terms. And so we get t minus a squared times 4t minus 3b minus a equals 0. This one gives me t equals a when I set a equal to 0. This one gives us 3b plus a over 4, which is weird. But remember that they told us that a, again, this is super hard. It's kind of more like a BC, really tricky topic. But they told us that 0 was less than a, which was less than b. So 4b over 4, that would be equal to 1. To 1b, sorry, to b. But a is less than b. So I know that this value 3b plus a over 4, it has to be smaller than b. Right? It has to be smaller than b because, right, 3b plus a, like a is smaller than b. So this isn't quite yet to 4b over 4. So that's important. So anyways, when I'm looking at, question 2, part 2, it says the particle is at rest at time a. Yes, it is. It's at rest at a and at 3b plus a over 4, because those were our zeros for velocity. So 2 is true. Then b is asking, is the particle moving to the right at time b? Well, we just talked about that this 3b plus a over 4 has to be smaller than b. So that means b is in this very far section. Okay, now I didn't plug in everything. What I did is I plugged in 0, right? And we're going to plug it into the velocity. So I plugged in 0 into this line here. And t minus a squared is 0, like I plugged in 0 for t. So negative a squared is positive. This is always positive because it's even. And then 0 minus 3b minus a. Negative 3b and negative a, they're both, since we know 0 is less than a, less than b, they're both normally positive values. So if it's negative 3b minus a, that's going to be a negative. Positive times a negative is negative. Now I didn't plug anything else in. I just thought to myself, that's squared. And that's to the first power. So the squared, it's not going to change signs. So at a, it doesn't change signs. And then at the other point, it was odd, so it does change signs. So this is decreasing, decreasing, and increasing. So our particle is moving to the right at, this last interval, which is where b is. So number 3 is also true. Again, you're not going to get this on the AP test. If you understood that, great. If you're like, whoa, that's kind of a cool question, great. If you're like, I have no clue what just happened, don't sweat it. It will not be on our final. Okay, number 10 is more likely to be on our final, and it was a calculator question. And this is kind of that same question, but at the level that you might see. So as a calculator question, it says the particle is moving to the right. And to me, the easiest way to do this, honestly, was when it says moving to the right, at rest, changing directions, those all have to do with velocity, right? Like moving to the right is when the velocity is positive. At rest is when the velocity is 0. And changing directions is when v changes signs. So, that was for number 1, number 2, and number 3, kind of what we're looking for. So if I have a graph of the velocity, that's the very easiest thing. You'd have either used your calculator to get, the derivative and set it equal to 0, or you could have even just graphed it. And that's what I did, is I just graphed it. So I graphed it. We have 2. And we have 5, right? I just did the derivative of, now make sure that we change the t's to x's because we're graphing it. And I did the derivative because we had position, we want to graph velocity. So it says the particle's moving to the right for t is greater than 5. Yes, it is. Then it says the particle's at rest at time 2. Yes, it is. It says the particle changes direction at 2. It doesn't, it stays negative. All right, and then next up we have this question here. It says f is decreasing, that's f prime of c is less than 0. F is concave up, that's f double prime of c is greater than 0. And x has an x-intercept, that's f of c equals 0. Anytime you have these sorting questions like this, 99.9% of the time, one will be positive, one will be negative, and one will be 0. So you're just looking for that and then just putting them, from negative to 0 to positive. Right? Negative is less than 0 is less than positive. All right. Next up, we have this question's given velocity graph. It says, when would the bug change directions? Well, that's just when the velocity changes signs from positive to negative. Super easy. And then I think this is our last question, if I'm correct. Yeah. So this question is asking about the speed of the particle. It is a non-calculator, so it's a little bit hard, but we want to know when v of t and a of t are the same signs. The derivatives are easy. I'll let you do those on your own. So you take the derivative, factor out a 6, solve for the zeros. We get 3 and 5, and I made this first number line. Okay, then I took the second derivative, 12t minus 48, set that equal to 0, we get 4. I made the second number line. And it's kind of hard to see where they're the same. So what I do is I kind of just draw these lines, these extension lines, from 3 down. I see this on the left is positive and negative. Those don't match. But then in between 3 and 4, right, this is negative and negative. They do match. So 3 to 4 works. Then from 4 to 5, right, this is now positive but negative. So they don't match. Then after 5, we have positive and positive. They do match. So my choice is E. All right, I'm going to split this video into 2 sections. I would take a break before working on the free response. Otherwise, you might get overwhelmed and just kind of lose focus. So watch the free response in the upcoming video.